Alright, sorry that I had to stop the video there and finish it up in this second video. But if you only have to check the last page, then you can just watch this last video here. So we're in the middle of doing the objective or the learning target for 1.4, where we're dealing with equations of lines, finding the equations, when also given parallel or given information like parallel and perpendicular. And that's what these last two examples deal with. So we want to write the equation again in slope-intercept form. So just to recall, y equals mx plus b. That's the form we want. Here we're given the point. So here's x1 or xy, our point. You can call it x1, y1, 2. And now we're saying it's parallel to this equation right here, y equals 4x minus 7. So this is something you got to remember. Parallel means same slope. So when dealing with this equation, I'm looking at this piece right here, the 4. I'm ignoring the minus 7 altogether. So I know my equation starts off like this. Y equals 4x plus 7. Or not 7, sorry. I don't want to confuse you there. Plus, I don't know the y-intercept, plus b. Plus, it wouldn't have been plus 7 since it was minus 7 there, as I just see that. So now, this is where this point comes into play. 5, 3, plug them in for the x and y values to help you solve for b. So, 3 equals 4 times 5 plus b. So 3 equals 20 plus b. Then I can subtract the 20, and I get b to equal negative 17. So then what that tells me is now I have my slope, I have my y-intercept, I write the equation at the end, y equals 4x minus 17. Okay. All right, so number 2 is the same process, except you're now told perpendicular. So here we have perpendicular, which means opposite reciprocal slopes. So what does again mean to be opposite and reciprocal? So here's my slope, negative 2. To do the opposite, I change the sign, so it becomes positive 2. To do the reciprocal, I flip the fraction 1/2. So that's the slope I'm going to use for my equation. So that's what the m is going to equal. Sorry, the equal didn't draw nicely on there. So my equation starts off by saying y equals 1/2 plus b. So now I'm going to use this point for my xy. Plug those in. So y is 7 when x is negative 2. So I get 7 equals negative 1 plus b. Add 1 to both sides. And b equals 8. So now I have my slope, my y-intercept. My equation is y equals 1/2 x plus 8. And I have my equation. Don't be surprised. I would definitely expect at least one of these, parallel or perpendicular, to be on your test. So make sure you remember which one is which. All right, let's get down to our last objective. We just have 4 more problems to work with. So this is what we were talking about in our last lesson, which our learning target is I'll be able to graph and apply linear inequalities. So with our inequalities, this is where we're going to have to shade and also remember with determining whether or not to include the line or not to include the line, meaning is the line solid or is it dashed? So just a couple things to remember. Greater than or less than is dashed or a dotted line. The When it has the equals, it's solid. And then if it is less than or equal to, that we shade below. And then if it's greater than or equal to, we shade above. So when I look at the first one, what's really nice about the first one is y is all by itself. So here's my y-intercept. There's my slope. So I can go ahead, start at -3 on my y-axis. Slope is 2 over 1, so up 2 to the right 1, up 2 to the right 1. So repeat that process. Or I can start at the point, go down 2 in the back 1. So I'm doing the opposites. So now I look at this inequality sign. So I go over here and say, oh, less than means dash. Okay. And less than also means below. Okay. So dashed. I'll draw my arrows. I want to shade everything below. All right, that takes care of the first one. All right, the second one, I have to do some algebra. So I got to get y by itself. I'm going to subtract 2x from both sides. So when I do, I have -3y is greater than or equal to -2x plus 12. Divide everything by -3. Ooh, I'm dividing by negative, so don't forget, you're going to flip your inequality sign. So I have y, and I got to flip this. Less than or equal to. 2 negatives here make a positive, so 2/3 x, and then 12 divided by -3, -4. So now, when I look at this inequality sign, it has the equals. It's solid. Okay. It's a less than or equal to, so below. So now here's my slope. Here's the y-intercept. So my slope is at -4. My y-intercept, my y-intercept is at -4, misspoke there, so -4. My slope is 2/3, so up 2 to the right 3, up 2 to the right 3. Going in the opposite direction, down 2 to the right 3. So I know it's solid, so I can connect my points, make a nice solid line, and the shading is below. Right, one more of these to practice here. So on this last one, same thing, just like I did with the one before. We'll subtract 5x. -4y is less than or equal to -5x minus 8. Now I divide by, dividing by another negative. That means I'm going to flip that inequality sign. So y is greater than or equal to, 2 negatives make a positive, 5/4 x. 2 negatives make a positive, so +2. So when I look at that inequality sign, it does have the equals, so it's solid. And since it's a greater than or equal to, we'll shade above. So now, I start here at 2, y-intercept is 2. That was my y-intercept. Here's my slope. So, up. So I need to go up 5. 1, 2, 3, 4, 5. Just enough. Over 1, 2, 3, 4. So I can go down 5. 1, 2, 3, 4, 5 to the right 4. Don't have enough space, but that should be enough at least so that I can make a nice solid line. Then the shading says to go above. right, so I wouldn't be surprised. I bet you'll have one or two of those just like that on your test. All right, last one. So we did a couple examples like this in class in the 1.5 notes. It says a school system is buying new computers. They will buy D desktop computers costing $1,000 per unit and N notebook computers costing $1,200 per unit. The total cost of the computers cannot exceed $80,000. Wow, that's a lot of money. So A says, write an inequality that describes this situation and, graph the inequality. Okay? So they decided to use, if you see in the graph here, D for desktops, N for notebooks. I still might use X and Y. So I might just say here, I'm going to let X equal the number of desktops. But if you use D, like I think the key of the notes actually might have, that's just fine too. Y is the number of notebooks. All right, so now what I can do is write my inequality. So it costs $1,000 for every desktop I buy. So 1,000 times the number of desktops, X, plus 1,200 times the number of notebooks cannot exceed but can be equal to basically my budget, okay, of $80,000. So now one of the things I can do is I can now try to graph this inequality. So in order to do so this would be the part B. So it's also, I'm still finishing up A, graphing. So I can subtract 1,000 X. So I have 1,200 Y is less than or equal to negative 1,000 X plus 80,000. Then I'm going to divide by 1,200. So if I do that, I get Y is less than or equal to, so this reduces as a fraction to be negative 5 over 6x. 80,000 divided by 1,200 as a decimal, that's 66.6 repeating. Now, if you put this as 200 thirds, I'm okay with that too. I know we don't get really super nice numbers on this. But what this means is I'm starting here at about 66.6 computers, and I'm going down roughly 5 units and to the right 6, which makes this a little bit more challenging to graph. But I kind of estimate my slope here, since I'm kind of a little bit more than the middle. I go 1, 2, 3, 4, 5, and then over 1. Then I go over 1, 2, 3, 4, 5, 6 to estimate where that actually ends up being, which is right here. So I know it's kind of hard to see that because the pen wouldn't show up. But what I did here was I counted down 1, 2, 3, 4, 5. Then over 1, 2, 3, 4, 5, 6 to get that point. So I know it's a solid line. Go ahead and connect those two. And I have my inequality. It does say less than, so I shade below. So my solution region is in here. So now it asks, school wants to buy 50 of the desktops and 25 of the notebooks, okay, can they do so? So looking at it graph-wise, wow, 50, 25 looks like right on it. So the question really becomes, is that enough? So one of the things that I can actually do, sorry, I have to get that point there on there a little bit, is I can take my original inequality, switch colors, and plug in that point, this point, which is 50, 25, and see if it makes this inequality true or not. So if I go 1,000 times 50 plus 1,200 times 25, is that less than or equal to 80,000? So 50 times 1,000 is 50,000. On my calculator, if I take 1,200 times 25, that's 30,000. So if I add those up, I actually get 80,000. 80,000 is less than or equal to 80,000. So this one is a check or a yes. They can, or they do have enough money to buy their computers. All right. Good luck on your test. I hope everything goes well, and I hope these two videos were helpful for you. Have a great day.